Good morning to one and all present here. I am Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I am going to share a small article regarding MapReduce. So MapReduce is basically a programming model and a distributed computing based on Java, and it has two tasks. One is map task and reduce task. So for writing applications that can process big data in parallel on multiple nodes, MapReduce provides analytical capabilities for analyzing huge volumes of complex data. So MapReduce is a processing technique and a program model for distributed computing based on Java. So the MapReduce algorithm contains two important tasks, namely map task and reduce task. So here the map task takes a set of data and converts it into another set of data where individual elements are broken down into tuples. Like each tuple will have a key value pairs. And again the reduce task takes the output from the map as an input and combines those data tuples, key value pairs, into a smaller set of tuples. So the major advantage of MapReduce is that it is easy to scale data processing over multiple computing nodes. Under the MapReduce model, the data processing primitives are called mappers and reducers. So the algorithm behind the MapReduce program is, so it has three stages. So the first we are giving an input, and then map task will do the map function, and the reduce task will use the reduce function, and it is giving the output. So the MapReduce program executes in three stages, namely map stage, shuffle stage, and reduce stage. So first, in the map stage, the map of mapper's job is to process the input data. So generally the input data is in the form of file or directory and is stored in the Hadoop file system. So the input file is passed to the mapper function line by line. So the mapper processes the data and creates several small chunks of data. And next it goes to the reduce stage. This stage is the combination of the shuffle stage and the reduce stage. So the reducer's job is to process the data that comes from the mapper. After processing, it produces a newer set of output which will be stored in the HDFS. So there are three phases. So one is the input phase, map phase, intermediate keys, combiner, shuffle, and then the sort, and reducer, and then the output phase. So first, in the input phase, here we have a record reader that translates each record in an input file and sends the parsed data to the mapper in the form of key value pairs. So next is the map. So map is a user defined function which takes a series of key value pairs and processes each one of them to generate 0 or more key value pairs. Next is the intermediate keys. The key value pairs generated by the mapper are known as intermediate keys, and the combiner, it takes the intermediate keys from the mapper as input and applies a user defined code to aggregate the values in a smaller scope of one mapper. Next is the shuffle and sort. It downloads the grouped key value pairs onto a local machine where the reducer is running the individual key value pairs are sorted by key into a larger data list. So the data list groups the equivalent keys together so that their values can be iterated easily in the reducer task. Next is the reducer. So the reducer takes the grouped key value pair data as input and runs a reducer function on each one of them. Here the data can be aggregated, filtered, and combined in a number of ways, and it requires a wide range of processing. Once the execution is over, it gives 0 or more key value pairs to the final step. And finally, in the output phase, we have an output formatter, and that translates the final key value pairs from reducer framework and writes them onto a file using a record writer. So the working behind the MapReducer is, during a MapReduce job, Hadoop sends the map and reduce task to the appropriate servers in the cluster. So the framework manages all the details of data passing, such as issuing task, verifying task completion, and copying data around the cluster between the nodes. Most of the computing takes place on data on local disk that reduces the network traffic. After completion of the given task, the cluster collects and reduces the data to form an appropriate result and sends it back to the Hadoop server. Typically, both the data and the input and output are stored in a file system, so the framework takes care of scheduling tasks, monitoring them, and re-executes the failed task. So here the MapReduce framework consists of a single master job tracker and one slave task tracker per cluster node. So the job tracker, the master job tracker is responsible for resource management, tracking resources, consumption, availability and scheduling the jobs components, takes on the slave monitoring and re-executing the failed tasks. So here the task tracker execute the task as directed by the master and provides task status information to the master periodically. So the job tracker is a single point of failure for the Hadoop MapReduce service, which means if job tracker goes down, all the running jobs are hated. Thank you.